Hello, welcome everybody to DevSecOn 24, another talk. My name is Rahul. I'm the co-founder here at V45, and today I'm excited to be talking about threat modeling wins for Agile AppSec. Like many others, it's my first time at DevSecOn, and I'm quite excited to be here speaking with a plethora of other speakers. So an exciting day for me, and hopefully all of you guys and girls have a lot of fun in this talk as well. Before we get started with the actual talk, a little bit about myself. My name is Rahul. Like I said, I'm one of the co-founders here at V45. We're essentially a company kind of helping a lot of product development teams, kind of helping them measure, scale, and implement a lot of application security processes. Personally, what keeps me up at night, things that you see here on screen, right? Largely working with clients on application security automation models, trying to make them more familiar and help them realize their DevSecOps value proposition, threat modeling, which is one of the things that we're going to talk about today, or the main thing that we're going to talk about today. That's something that I've been getting my hands dirty quite a lot in the last few years. And then finally, a lot of movies and a lot of popcorn. So that's something that I'm really kind of looking forward to every weekend, especially ever since we started living practically at my basement ever since the pandemic started to hit. Okay, with that, let's get started. So over the next 45 minutes or so, we are largely going to be looking at this phenomenon. And I'll tell you why I call this a phenomenon called threat modeling, because we're going to kind of look at what threat modeling really means more as a noun and as a verb. And I have a reason for that, because you've probably heard this a lot. You've probably seen the word threat modeling being thrown around in discussions with product engineering teams. You've seen them thrown around as activities and tasks within application security programs. But really what we're going to look at is why do threat models fail? And more importantly, I'm just going to present my version or my option to what we think would be probably a decent way to kind of scale this effective threat modeling piece within application security automation pieces. And one of the things that I always like to say is, if application security was a website, threat modeling is that page with the highest bounce rate, because those are the things that people are always talking about. They're really kind of interested about it, but nobody is really doing it, right? So what we're hoping to achieve at the end of this 45 minutes is for us to kind of really understand some of those building blocks of threat models, application threat models to be more specific, and kind of look at the schools of thought that would really make sense for product engineering teams to kind of implement and scale threat models from that perspective. We're also going to be looking at Threat Playbook, which is an open source framework that we at B45 kind of developed around 3.5 years ago. And we're also kind of looking at how Threat Playbook can be one of the means to implement application security at scale using threat modeling. And finally, we're also going to be kind of looking at how the security testing framework would kind of seamlessly integrate with threat model, because everybody's talking about the as a code model. So we had security as a code, and today we're going to look at threat modeling as a code, and how is it that we kind of integrate both these pieces into a well-oiled application security machinery. So let's start off with something that everybody's been talking about, the whole state of application security today. I know that we've had a lot of talks today. We've had a lot of people talk about some of these topics, but I just want to kind of touch upon a few salient features, if you will, of what AppSec 2.0 or 3.0 really kind of looks like today. First of all, we're seeing a huge increase in tooling. And tooling across multiple units, right? We're not just talking about tooling in terms of automation. We're actually talking about tooling in terms of developer platforms. You're talking about tooling in terms of infrastructure as code. Pretty much across the board, tooling is something that's going on as we look at product engineering teams at scale. We're also looking at deployments really kind of scaling, and with those scale deployments, you're actually seeing security test iterations increase multifold as well. The DevSecOps wave, as we call it, I don't even know if it's a wave anymore. It's been a while since people started implementing it. So the whole DevSecOps wave has kind of brought with it this whole feedback looping system, which is kind of really cool, because it's kind of increased our ability to understand security vulnerabilities that happen at the shift right model, which is essentially security vulnerabilities that happen at production, and kind of help them really kind of bring that back into the forefront in terms of being more proactive in terms of those security vectors or security vulnerabilities, being able to, teams being able to really kind of understand that before they actually happen. And one of the things that we're going to talk about today, which is quite interesting, is this as a code execution model, right? We started off with security as code when the whole wave started off. And today we're going to kind of look at threat modeling as code, but you had infrastructure as code, you had compliance as code. And today we're going to kind of see how the as a code model kind of really seamlessly integrates in within the threat modeling process as well. And finally, a lot of impetus on not just the typical traffic light indicators of high, medium, and low security vulnerabilities, but the whole model today is in terms of really understanding those devil in the details of the metadata that these security vulnerabilities and these tools kind of give to product engineering teams. A lot more analysis in terms of what the story of each and every vulnerability is. So all of these things are kind of really interesting from a security perspective. When we kind of talk about threat modeling, one of the things that and we've been in we've been in application security for almost a decade now. And ever since we started off, there's this castle that's built about threat modeling in terms of it being this panacea of a pill that kind of solves every problem in application security. And I always tell this to my sales and marketing teams as well, in terms of really be careful about positioning two things, right? Be careful about positioning DevSecOps, and be careful the way you position threat model, because both of these things are simply wonderful utopian dreams that everybody can kind of achieve when you talk about it. But then when you actually get down to business to try to kind of really help them fix this in brass tacks, it's really, really different. And that's one of the reasons, but we really want to be sure that why does this happen? And why is it that threat modeling, which seems really, really interesting when you talk about it, seems really aspirational yet achievable when on paper, what is it that really happens when you kind of take that to ground zero? And to understand why threat models fail, it's very important for us to ask ourselves the initial question is in terms of what really is the definition of threat modeling. And that's really where one would like to start off this journey of understanding threat modeling in application security scaling programs. And for us to kind of understand that, it's really important for us to go back to school and really think of the blind man and the elephant in terms of understanding threat modeling, right? Because threat modeling, similar to the fable there, is really kind of dependent on what you're looking at, right? And just like the seven men there, you could kind of look at multiple perspectives of threat modeling. It really depends on which part of the elephant that you're really looking at or trying to look at, right? So you could either, it ranges, threat modeling really ranges from things from finding issues in design and architecture, which probably is the fundamental definition of threat model, way up to anticipating security incidents, which is one of the most contemporary view, if you will, of looking at threat models. So it really kind of depends on what really is your motivation, because the motivation to threat model really kind of drives home the initial stepping stone of where you're going to take the threat model from. And one of the primary reasons that I feel, and we've seen this not work with multiple engagements as well, is the primary reason for threat modeling to largely fail is really not understanding the why of threat modeling, right? So why is it that teams would like to do threat modeling? Because there is no one size fits all. It really depends. I mean, if you're a security architect, you might probably want to do threat model to identify securities at an architecture level, at a blueprint level, right? If you're a pen tester, you could use threat models as a precursor for you to do your pen test. It's a great way for you to kind of get a lay of the land of the application, for you to kind of really understand where the attack vectors are and what kind of strategies you could implement from a pen testing perspective. If you're an automation engineer, you could use threat models in a way to kind of really plan your security regression scripts. And we'll see how that works in the next couple of slides. But long story short, I think it's really important for each individual team to identify what really are their motivations to do a threat model. Because like I said, there simply is no one size fits all. And just like in anything else in AppSec, right? No two applications would be the same, and therefore no two application security programs would be the same. So I don't think threat model is any different in that same view of the world. And the second reason we've kind of seen threat models fail is really an overemphasis of how. Because the first thing that people think about in terms of threat model is this humongous, huge visual documentation that you see, where you kind of feel that that's just going to be a huge behemoth to even get over with, right? What is the methodology that I should be using? Should I use Stride? Should I use Pasta? Should I use something else? Should I find out a methodology for myself? What tool should I use? Can I do this manually? Should I use a commercial tool A? Should I use a commercial tool B? And who's going to be doing this? And how do I need to document this? Do I need to document this in Jira? Do I need to write documentation for this? There's just so many questions that we get entangled in terms of the operational logistics of performing a threat model, right? And there's this really unsaid complex rule in product engineering that says that threat models cannot be simple, because threat modelings have to be complex, right? And I don't know where that came out from, but again, just something that adds on to complexities as well. So simple rule that we follow here, I also tell people, is document what you do, not the other way around, right? And the same thing works for threat modeling as well. So talking about threat modeling schools of thought, and this is really where we start getting to the beef of today's talk, is really, from our perspective, there are two specific schools of thought in threat modeling: story-driven threat modeling and component-driven threat modeling, and quite self-explanatory in terms of the verbiage there. A story-driven threat model is really driven from a perspective of what if, and you also probably call this an abuser case driven threat modeling, right? Something that a lot of pen testers use, and we at B45 started using this from a pen testing school of thought as well. So you have an application, you have a functional walkthrough of the application, then you ask a question in terms of what if this attack vector was to actually be weaponized, what would happen there? So that's a what if scenario of a story-driven threat modeling. A component-driven threat modeling, which is what most organizations would do, is more of a system-driven engagement, where you kind of take an application, you look at the various components that you have in that application, and you kind of figure out what those inherent vulnerabilities of or weaknesses of those components are. So it's more of an inside-out driven approach, whereas the story-driven threat model is more of an outside-in driven approach. The fundamental building blocks of the story-driven threat model are abuser cases or abuse cases, whereas that in component-driven threat models are known issues. And let me explain that a little bit. So in a story-driven threat model, you have a user story, and that user story kind of breaks down into what we call an abuser story. And that abuser story is what you would kind of use as a starting point to frame your what-if scenarios. On the component-driven threat modeling perspective, you already have these existing components, and you're relying on known inherent vulnerabilities or weaknesses that these components have. So you're kind of using that as your bedrock, if you will, to kind of build onto your strategy of drawing these complex or even simple threat models. A story-driven threat model in usual cases is usually done post-design or development, because you're kind of looking at it at a what-if scenario. So in most cases, it's just a rule of thumb, is you'd probably use the story-driven threat modeling at a stage when the application is already in the post-design or during the development stage. Whereas the advantage of the component-driven threat model is you can actually use it right before it's developed at a pre-design phase as well. And while we're talking this, you'll probably be able to kind of appreciate what we spoke about in the earlier slide is in terms of your motivation to do threat modeling. So as and when we keep going down this chart, you'll see that at every stage here, it kind of changes in terms of who the persona in product engineering is going to be doing the threat model, and what are the outcomes and motivations of that particular persona. So if you're an application security engineer, your motivations could be different. If you're a security architect, your motivations could be different. So it really depends upon which two different schools of thought kind of appeal to you from that perspective. Talking about personas, story-driven threat modeling, usually a favorite amongst security professionals, security engineers, and developers. And a component-driven threat model is usually something that both security professionals and architects kind of tend to use, because of its inherent nature of being able to kind of be used at a stage right before the first line of code is kind of written. Interestingly, and for anybody, for all you automation geeks who's listening in today's program talk, if your focus of threat modeling is depth, then you probably need to use a story-driven threat model. But if your focus is more on scale, that's when you use component-driven threat model. Because as you start drawing your abuse cases, remember, abuse cases are essentially stemming off use cases. And use cases means functionalities. Functionalities mean edge cases. So therefore, if you're focusing on depth, maybe a story-driven threat modeling is your cup of tea. And if you're focusing on scale, you need to kind of look at more component, because more component, and that's the reason we kind of see a lot of tools on the component-driven side of the fence. And I'm not going to be promoting any tools here. So if you want to figure out what those tools are, that's a little bit of a paper exercise for you. But mostly you see a lot of commercial tools on the component-driven threat modeling side of the fence. And on the story-driven front, you don't have as many commercial tools. We're going to be looking at Threat Playbook, which is open source. We're going to be looking at that in the next few minutes. Or you kind of do this manually. That's where we started off doing. So we pretty much draw mind maps of sorts as soon as you know your application in terms of what it does, and you kind of draw these mind maps or branch off trees, if you will, that kind of map your threat models. And so today we're going to let's look at this in a little bit more detail. I know we talked about this, but in a component-driven threat model, you pretty much start with a questionnaire. Again, this is talking from the view of the world of you being able to do this from a tool. So therefore, you start off with a questionnaire. You pretty much enter things like what technology stack are you using? Are you under some kind of a compliance a mandate like a PCI or a HIPAA or a SOC or something like that? And then which domain you're in, and then think of it as actually filling out a questionnaire that kind of presents something at the end of the process for you, right? So the questionnaire is where you kind of really define your application, or you kind of define your scope. And then based on those details, remember, you have your technology stack, you already have those components for those stacks. So the platform is going to pretty much kind of give you this buffet of process flows and data flows that you kind of use them to define the way that your application behaves. And then depending on those components, you would have threats. And then each of those threats would have one or more of countermeasures that you would kind of implement. So this is a very top level view of what a workflow of a component-driven threat model looks like. But what we're going to be talking about in more detail today, which is because that's something that's very close to us, and I've personally, along with the team, have had the opportunity to work in this much more than the component-driven threat model. So we're going to talk about more on the story-driven threat modeling today. So from a story-driven threat modeling perspective, the anatomy is very simple. You have the use case, which really tells about what the functionality of that particular scope or that application is. A use case would have one or more abuse cases, which means what can go wrong with that functionality. So that's really the abuse case. And then you have the attack model, which essentially tells you in terms of how would an abuse case really come to life. So this is the primary three building blocks of a story-driven threat modeling. What's the use case? What are the various abuse cases for a use case? And how can those abuse cases really come to life? Let's look at this from an example. Let's take an application where the user story is, imagine there's this, some kind of a repository which has notes. And then as a user, you would want to search for your notes using the search feature in that application. A very random application, a very random use cases. So just imagine that there's a repository, there's a search bar, and you're searching something within the search bar, and it happens to be notes, right? So that's a user story. That's what the developers are going for. Potential abuser stories for the same user story would be that as an abuser, maybe I want to search for notes that don't belong to me, breach of confidentiality. Maybe as an abuser, I would like to look at notes that potentially disclose sensitive information, right? A breach of confidentiality again. Now, as you can see, this particular user story has two abuser stories. Now, each of these abuser story would have one or more of attack models. So we're just going to take the first abuser story, which essentially says that I'd like to search for user notes that do not belong to me and disclose potentially sensitive information. And how could you potentially exploit this? You could do man-in-the-middle attacks. You could probably do injection attacks or OS command injection attacks. You would probably do a URL redirection where you kind of take the user to somewhere else. and then boom, something happens, right? Again, very top level examples here. So you have the user story, you have the abuser story, and then you have the attack models. I want to take a little bit of a break here because I want to show you about Threat Playbook, because this is the framework that we're going to kind of use to kind of drive this whole story-driven threat modeling. So let's look at how Threat Playbook kind of works within the security-driven process. Okay, so this is the Threat Playbook interface. Remember, it's an open source platform. I'm going to pop in the link to this GitHub link repo in case you didn't catch it in the earlier slide. And then feel free to kind of download it. We have a lot of people who've kind of downloaded it, and you can do what you want with it. There's no, again, just like we've been saying, there's no one size fits all with Threat Playbook as well. What you're seeing here is a temporary UI that we've kind of put together. It can be much more better looking than this, and I just kind of put this for the sake of today's demonstration. But essentially, what Threat Playbook is it's an open source framework which is pretty much driven by YAML scripts, Python, and a MongoDB database, right? So essentially, what Threat Playbook does is it kind of gives you the capability to link use cases to abuse cases, and then finally to security testing scripts as well. You could have the actual fabric downloaded. You could either use it as it is, or you could wrap around a simple UI like this, or something else for you to kind of give it a more interactive flavor. So what we're going to look at today is, if you go to projects, and this is the overall dashboard, you'd see how many projects are there, how many user stories. Obviously, you would have more than 4 user stories. I just managed to type in something today for this demonstration. And then you would have the various vulnerabilities here by severity and the threat models by severity. So let's kind of delve into what goes on with Threat Playbook, right? So I have 2 projects here. You see an expenser project, and then you see Juice Shop, which is obviously the OWASP Juice Shop. So when you click on the project, you see here, it gives you an understanding in terms of how many user stories are there, how many abuser stories, what the threat scenarios are, and what the vulnerabilities here are, right? So let's look at a simple user story. Again, please, you can oversee the way this project headers are written. Like I said, I'm not the best when it comes to writing a good UI. I'm just here to kind of tell you in terms of how we could use this. I'm sure there are better folks out there who can kind of make a better UI of this. But moving on, we've got a simple user story called upload expense, right? So essentially what it's intended to do is that it's an expense management platform. Assuming that it's an expense management platform, somebody is trying to kind of just upload their expenses to the platform for it to be kind of processed. So this is a user story. And you click here, you can actually give what that user story is from a functionality perspective. And then you see 3 abuser stories linked to it, right? You have the first abuser story, which essentially is manipulate expense information. You have tag expense to someone else, or something even more worse, which essentially is bring down the system using a malware. Now let's look at this first abuser story. You can actually give out a description here. In fact, actually, at the user story level, you can actually kind of tag documents, or you can kind of give out some kind of an image here. So feel free to kind of use it how you'd want to. And when you actually come to the abuser story here, again, you could kind of tag some images or something like that. There's enough space here for you to do that. So here, interestingly, what's happening here is here's where what we saw in the slide previously. Each of these abuser stories can be potentially weaponized using 3 or more multiple ways. So in this example, we're seeing 3 ways. For example, manipulate expense information. You could do that using the SQL injection, limit bypass attack. You could do that using compromising the manager's password, or you could do that using compromising the auth token. So that is the threat vector here. And when you actually look at the threat vector, when you click on the threat vector, it will actually tell you what is that attack vector, which essentially is the SQL injection. You also have this connected to the CWE, so it'll tell you a SQL injection is an 89. And then from a remediation perspective, you can actually, this is mapped to the ASVS, which tells you in terms of how you can go ahead and test this particular vulnerability, right? Again, just sake for the demo, not all of this information here could be practically accurate for this particular example, but just to give you a sense of what the fabric of Threat Playbook looks like. Right, so each of these threat vectors here link up to one or more potential vulnerabilities. And what's interesting is you can actually kind of link how you would test that vulnerability, right? For example, to test for SQL injection, you can either do an automated vulnerability scanner. For example, I can actually link up tools like Zap or Burp Suite or Arachne or something like that. And then as those tools execute, you can actually, and if they find that vulnerability, and I'll show you where it found, where you could see that, it'll actually give you a simple test case executed here. Or you could do this manually. You could check for these issues manually, or if there's an existing exploit that is available for this vulnerability, you could link that up as well. Or you could use source composition scanning, right? You could use tools like Snake and other things for you to kind of check for that same vulnerability. And then finally, you could use static analysis as well, which is what we've used here. So these are the various ways in which you could potentially check for this vulnerability. So I'm just going to go back here to the project. I'm going to show you the vulnerabilities here. So you see all these vulnerabilities. These are the various vulnerabilities that the various tools have found. So depending, and because we have the mapping of the CWE here, as and when the tools find that particular vulnerability, it'll say that this particular vulnerability has been found. And because of the fact that we've potentially mapped a vulnerability to a threat vector, so now you have a link between a threat, a vulnerability, the tool that found that vulnerability. So which means that tomorrow you can actually look at all of your threats and say, okay, I've got 15 threats and I've got 20 different vulnerabilities. Which of these vulnerabilities map to which threats? So if there's a threat that does not map to a vulnerability, it means that that particular threat has not really as yet been weaponized or has not been found as yet. Now, similarly, if there's a vulnerability that's not mapped to a threat, that simply means that, okay, there's some vulnerability that's come either by design or by disaster that has not been envisaged in your threat modeling process, right? So which means that's a better way for you to go back to your threat modeling drawing board and says, hey, how did we miss this vulnerability? What could have caused this vulnerability? And then you go ahead and refine your threat modeling from that perspective. So whichever, you can either do that at a component level, or you want to do that at a user story or a story level, you could do that as well. So the objective of the threat playbook really is for us to really kind of bring about that link between threats, vulnerabilities, and then the tools that found those vulnerabilities, and therefore establish that end-to-end connectivity between the threat and the vulnerability. But more importantly is also to kind of, and all of these things at the back end, all of these user stories and abuser stories are all simple YAML scripts, right? It's just YAML scripts that we've written in the background, and you kind of load all of these information on it. And because of the fact that you're trying to kind of really break that down to its lowest common denominator being some kind of a code fabric, we're hoping that this is something that a lot of developers can potentially use for you to kind of just codify that whole threat modeling process. And as and when you have more abuser stories, one of the things that we've done is that we've kind of taken common abuser stories or common threat scenarios that's applicable for any application, right? It doesn't have to be just application A or application B. When you actually break down your security test cases, there are some generic security test cases that's applicable to any kind of app. And then you have specific test cases that's applicable only to that particular application. So if there's a way for us to kind of collate all of these generic security test cases and therefore the generic threats, you can actually load them as common abuser cases. And that's something that you're working on right now. We're going to soon open source that as well, where we're kind of writing abuser cases that you could just plug into Threat Playbook, and then whatever app that you're using, you could just pull in those abuser cases without you having to kind of write them from scratch. And this is really, and let's see if you've got some scans here. No, we don't have scans here, but essentially what will happen is you actually run those scans, and you could take those scans and link them back to the main abuser cases that we see here, and therefore the threat scenarios as well. It also gives you a nice little threat map here, which you could kind of use to see what your surface vector of your components are. So depending on the number of use cases and abuse cases that you have, you can actually click on that particular vulnerability. Let's see if we find something here. Yeah. So let's say that you have a use case that you want to look at, or you want to have you want to kind of just delve into a particular type of vulnerability. You can actually do that here, and then it'll give you the appropriate mapping between the SQL, between that particular vulnerability and the ASVS standard that's used to validate that. So that's a little bit about Threat Playbook. And now let's go back to our slides and see how Threat Playbook and the story-driven threat modeling can actually trigger down to a security test automation process. Okay, so in this section, which is the last section of the talk, we're going to kind of look at how threat modeling can be a way for us to effectively drive security testing at scale. Remember, we talked about motivations of threat modeling, and one of the bigger motivations that teams are having today, which was one of the motivations that we had a couple of years back, is how can you kind of use threat modeling as an effective way to drive security testing at scale? And to do that, we're going to go back to our initial anatomy slide, which is that of the use case, the abuse case, and the attack model. We're going to add some little pieces to this existing anatomy and drive home that point. So you have the use case, you have the abuser case, you have the attack model. Now, there's one more component that we can add to the attack model, which is that of test cases. So remember we said attack model tells you how you would weaponize or how would an abuse case come to life. And the test case really kind of tells you how plausible are they. And that is really what the test cases do. The test cases, as the name suggests, are just a series of test cases that you can execute to see or to validate whether that scenario, that threat scenario that you've envisaged is actually possible in real life or not, which AKA is a security assessment process, be it a pen test or be it a vulnerability assessment, and we call them separately, right? Vulnerability assessment is separate, and a pen test is not the same. So a test case is really kind of that element of the threat modeling process that would help you kind of validate your threat models that you kind of seen in the previous stage. So let's go back to the previous example. We stopped the last time around with the third column, which essentially was what are those attack models and what are those attack scenarios. But then when you actually kind of look at the security test cases here, each of those attack models could kind of open up multiple security test cases. So let's look at the man-in-the-middle attack, for example. So to actually test for a man-in-the-middle attack, you would actually, A, check if the application renders all pages in HTTPS, or you would check for known attacks within the SSL TLS vulnerability, see if they're subjected to Poodle, Beast, or Suite 32 attacks or something like that. Or you could check for HSTS implementation in the application. So there are multiple ways, and as pen testers, those who are in the virtual room today, this is a very day in, day out process for you guys, for you to be able to test for a specific kind of vulnerability. And that's exactly what we're doing here. We're essentially kind of taking that attack model and we're kind of breaking them, we're kind of extending that to what various security test cases can potentially check for the existence or the absence of that particular threat scenario. So here's the link to an effective threat modeling automation scenario, right? So essentially, you have the threat, you have the test case, and then potentially a test case from an automation perspective can be done in 3 buckets, right? A, you have the tool route, which means that to execute that test case, you're using some kind of a tool. You're using a DAS tool, you're using a SAS tool, you're using a source composition tool. So there's this 100% automated. So there is a test case, and that test case can be purely executed using a tool. That's bucket 1. And then you have bucket 2, which means that these are test cases that cannot be executed by a tool, and that needs to be done manually. For example, let's say it's in the trained hands of a pen tester that you can actually check for a business logic flaw. No tool can find a business logic flaw or an edge case scenario, right? Now that's bucket 2. Those are the kind of test cases that you want to categorize as a bucket. And now the thing about bucket 2 is you can actually use automation scripts to actually simulate those attacks, right? You can use automation scripts like Selenium, Cucumber, robot scripts, or whatever that you have to kind of really take that edge case or business logic flaw that the pen tester has has found, and then you can actually find a way to simulate that particular vulnerability. So those are the vulnerabilities that are 100% manual. And then you have the third bucket, which is the hybrid bucket. And an example of a hybrid vulnerability would be a vulnerability where you could go only so far with the tool, and then you need to go manual. A perfect example is a parameterized DAS script, right? A DAS can potentially scan pages and crawl pages, but then there are certain DAS that you need additional context, like a credential, for example, the simplest context that you need to give to the tool for the tool to be able to kind of move forward and do what it does best. That's a good example of a hybrid hybrid type of test case. So depending on your test cases, you might have 100 test cases, for example, and each of those test cases would fall under one of these three buckets: either a tool-driven threat case, or a script-driven test case, or a hybrid test case, right? So once you've kind of categorized each of your test cases here, you can actually go ahead and see the whole 9 yards in terms of how this looks, in terms of a full process of threat model to a test case. So every time there's an application that comes in, you ask yourself the first question: is this the first time you're doing a threat model to that application? If the answer to that question is yes, you would actually do you first use the component-driven threat model. Like we said, though we're talking about story-driven threat model, there are certain advantages that the component-driven threat model gives you. And the advantage of that is scale. So in our experience, what we've felt is that it's that marriage between component-driven threat model and the story-driven threat model that gives you both the efficiencies of depth and scale. So for some of our customers in the enterprise segment, we've actually done that is we've actually taken a component-driven threat model modeling tool, any commercial tool. We take that, we first run that on the application, we get this entire bunch of vulnerabilities, right? That's going to give you like at least 60% of potential threats. And then you run the you run the abuser given threat models, which is more focused on depth. And then you kind of marry both of them together to get your 100% threats. And then you go around with your test case methodology. So if that's the first time that you're doing the threat modeling, you go through that flow chart. If that's not the first time you're doing a threat modeling, it's an iterative threat model, then you just go ahead and run a story-driven threat model on that additional iteration, or you run a component-driven threat model on that additional iteration of module. So once you've done this, you can actually really collate all of these threat models on a singular plane, and then you can actually start writing your automation scripts. So once you have your threat models, you have your test cases. Once you have your test cases, you can actually start automating them. So once you're done with your automation, as we saw in the previous example, in the demo, you can actually use frameworks like Threat Playbook for you to say, okay, I have my test case, I have my threat models here. I'm done with my security testing. I now have my vulnerabilities here. And then if there's a way for you to map your vulnerabilities back to your threats, which Threat Playbook can do using the CWE mapping, you're going to take the CWE from the vulnerabilities, take the CWE from the threats, kind of marry them together and say, okay, these are my threats. These are the vulnerabilities that have led to those threats, right? So this is a very, very effective way and a very practical way for you to not just look at threat models that can be implemented. You can kick off with threat models with very little red taping from that perspective, and also kind of look at a way to kind of scale in terms of being able to kind of use this across multiple teams, across multiple apps, and things like that. So finally, this is a diagram that I love, because this is my way of representing what DevSecOps actually means. What you have on the top are your typical building blocks of security engineering: plan, code, build, test, release, deploy, operate. What you have on the bottom are the typical building blocks of security engineering, which essentially is threat modeling, SAST, DAST, security and infrastructure, and then security monitoring and attack detection. And really the color coding here is really in terms of where do those specific security engineering building blocks fit in their respective product engineering building blocks. Threat modeling, largely on plan, now slowly getting into code. SAST, largely on code, moving its way through build into test, DAST, and security IAC, and so on and so forth. The good thing about Agile threat modeling is it kind of spreads across the board. So if you so threat modeling today can be used at the threat modeling phase with the conventional threat modeling phase. You can use that to model stories. Because now you have a link, you have an ability to codify your threat modelings, you can actually use threat modeling as a way to derive or write security test cases. You could use the same threat modelings and the security test cases to run your security test automation. And then you could also use threat models as a building block for you to detect whether the vulnerabilities that you found actually have a link back to those initial threat models there. So what's beautiful about this process is that the threat modeling is actually that single starting point that you could use to kind of derive multiple advantages through your security engineering processes. And as we keep moving forward with various other innovations that kind of come within the threat modeling space, we're kind of hoping that the initial orange kind of reeks its way through other phases of product engineering as well, because that's really the dream for us to kind of look at threat modeling as a multiple outcome driven engagement and not just a singular outcome that maps to a particular persona in product engineering. And that's really where we kind of looking to kind of take the whole threat modeling experience, if you will, from that perspective. So in summary, what we're going to look at, what we hope that we're going to that you take away today is look at what works for you the best. There is no one size fits all as far as threat modeling concerned. Understand what your motivations are, understand why you're doing threat modeling, and then it doesn't have to be complex. It could be something very, very native. It could be something that extremely back of the paper. As long as that works for you, we could look at a way to kind of formalize that in some shape or form. It's essential in enterprise segments, and that's one of the reasons we've seen it fails is because, hey, you might say, hey, Rahul, this looks good, but I'm not a mom and pop product engineering team. I'm actually a large enterprise that runs thousands of applications. Fair enough. And that's the reason you kind of look at how can you do that balance between depth and scale. And that's what we've seen is you could use component-driven threat models for scale, use abuser-driven threat models for depth, and have that healthy balance between depth and scale that gives you the efficiencies of both. It's important for us to make threat modeling more accessible. And by accessible, I mean make threat modeling that's more adaptable across multiple personas in product engineering. There is something for threat modeling. There is something for developers in threat model. There's absolutely something for security engineering in threat models. There is something for automation engineers in threat models. So it's all about being able to kind of derive that specific objective from each of these personas. So the more that we make threat modeling accessible, it kind of creates that whole, just like anything else, you have a shared responsibility model within threat modeling as well. So it kind of just removes that whole front ending of threat modeling to be just residing with one particular team, like security or architects, and kind of just democratizes that within the whole applicant security process. And then frequent threat modeling is not something that you would need to start off per sprint always. You can kind of use that in larger iterations. So you kind of start doing threat modeling. If you're doing threat modeling once a year, try and see how you can make it just twice a year. And then we'll break it down into more granular forms. So frequent threat modeling can eventually be a per sprint activity, but doesn't have to start off being at a per sprint activity. But it's that dream that you would still want to go ahead and chase. And finally, I think the win for threat modeling wins in AppSec, Agile AppSec, is a combination of it being incremental, it being consistent, and finally also being able to have that collaborative effort of multiple people joining in hands for this particular activity. So with that, we come to the end of our presentation today. I hope you had a valuable takeaways. Feel free to kind of pop in your questions on the chat window if you've not done so. Happy to kind of take any questions. I know this is quite controversial in terms of its adaptability and its kind of applicability. That's what I'm kind of gunning for, because it's not something I always like to kind of throw a cog in the wheel. So I hopefully have done that in today's presentation, and look forward to kind of answering your questions. And again, wonderful to be part of DevSecOn 24.